Hello and welcome to the release video for version 21 of the CodePeer Tool Suite. Since version 20, the CodePeer engineering team has added some great new features and has increased the stability of the tool so that you can confidently scan your Ada code for safety and security vulnerabilities. Before we delve into the new features coming in version 21, let's first quickly introduce the CodePeer Tool Suite for those who might not be familiar with the tool. The CodePeer Tool Suite is a selection of Ada analysis tools that are designed to aid software developers through their Ada software development lifecycles. The primary tool is, of course, the CodePeer Advanced Static Analysis tool. It is an Ada source code analyzer that can detect potential runtime and logic errors before program execution. The tool suite also includes GNAT Studio, AdaCore's flagship IDE, which makes editing, scanning, and maintaining Ada and multi-language software projects a breeze. There is also the GNATcheck tool, which is a coding standard checking tool for Ada. Developers, reviewers, and software managers can use this tool to enforce coding standard guidelines on software projects. And a tool called GNATmetric is also included, which is used to calculate statistical information about a piece of code, such as cyclomatic complexity. The CodePeer Advanced Static Analysis tool looks for three different types of issues which can occur in Ada code: runtime checks, logic errors, and race conditions. A runtime check can be anything that would cause an exception to be thrown at runtime, such as a divide by zero or an array index check, otherwise known as a buffer overflow. A logic error might be something like a loop without a reachable exit, an unreachable logic branch or unused subprogram, also known as dead code. And of course, a race condition would be an access to data from a task or thread in an unprotected way. CodePeer will look for all of these types of issues during its analysis. Let's quickly see CodePeer in action. We can see here a piece of Ada code opened in the GNAT Studio IDE. On the left side of the window, we can see the open project with the corresponding source files. You'll notice at the top bar a menu item for CodePeer. Let's start an analysis by clicking on CodePeer, then Analyze. That will bring up the settings menu for CodePeer. All of our options for this project are specified in the project file, so we will click Execute to start running CodePeer. The first thing CodePeer will do is a primary compilation of the software. CodePeer will then use the resulting abstract syntax tree to do its analysis. Once CodePeer completes, GNAT Studio will load the CodePeer results in a new tab. We can see that the results are listed by file and are categorized with a severity rating of high, medium, or low. If we click on a finding in the Locations window, GNAT Studio will navigate to the code where CodePeer flagged the issue. In this case, we can see that CodePeer found a high severity logic error and has told us that this code will always fail. We can also see some other findings highlighted in colors corresponding to their severity. This orange one, for example, corresponds to a medium severity array index check, otherwise known as a buffer overflow. So here, CodePeer is telling us that there is a medium probability chance that a buffer overflow may occur. GNAT Studio also gives us the ability to filter our results based on a few different types of criteria. For example, if we wanted to see only array index checks, we can select the relevant filters and GNAT Studio will only display the relevant CodePeer findings. A comprehensive webinar of the CodePeer Tool Suite, as well as other video resources for AdaCore tools and the Ada and Spark programming languages, are available on our website at www.adacore.com/webinars. Now let's talk about some of the new features that are available in the CodePeer Tool Suite version 21. The CodePeer engineering team has introduced a major enhancement to the Level 0 CodePeer analysis level by introducing the Infer static analysis framework. Infer was originally developed by Facebook to look for security vulnerabilities in Java, C, C++, and Objective-C code, and is used to analyze Facebook's Android and iOS apps, including Instagram, WhatsApp, Facebook Messenger, and the main Facebook app. It is currently used today by tech industry leaders such as Spotify, Uber, and Mozilla to detect and remediate software vulnerabilities. The CodePeer team has added support to Infer for the Ada programming language to leverage the advances in static analysis technology that was developed by Facebook and the open source community. The technology will replace the current Level 0 analyzers in version 21 and will increase the speed and accuracy of many checks. We can see Infer in action on some piece of Ada code here. In this example, we can see that Infer has told us about some potential errors that may have stemmed from a copy and paste error. In this example, we will always return the value of 1 since the operands of the divide are identical. We can see similar behavior here where Infer has detected duplicate code in different branches of a logical control block. Again, this could stem from a copy and paste error. Another type of issue Infer might check for is a typical range check like we see here. Infer has told us that these two arrays of the unconstrained type A have different bounds, which would cause the assignment in the subprogram body to throw a range check exception at runtime. Infer has statically checked this for us here and has even supplied us with a backtrace that we can use to triage the result. Version 21 of CodePeer includes an updated and interactive HTML view of the CodePeer report that can allow developers to view a centralized database of CodePeer results from their respective workstations. After an analysis is complete, a continuous integration tool such as Jenkins can automatically start the CodePeer web server, which will allow developers to access the CodePeer results via their browser over their local network. The CodePeer web server can also be started manually, like we see here. After the server has started, I can view the results by typing the IP address of the server. In this case, the address is my localhost with the specified port, and I can view and interact with the CodePeer results through my browser. Developers have the option to triage and categorize CodePeer results through a few different methods that are outlined in the CodePeer User's Guide. One option is to use pragma annotate in the source to tell CodePeer how it should categorize a finding and attach a message that will be displayed in the CodePeer report. As code is updated to fix potential errors detected by CodePeer, these pragma annotates will become stale and no longer relevant. CodePeer will now flag locations where this happens to allow code reviewers to remove unnecessary lines in the source code. All of these new features, as well as all of the bug fixes and stability enhancements that the team has made to the CodePeer Tool Suite, are intended to increase the quality of the tool's results, as well as make the tool easier to use. A complete list of new features and enhancements for CodePeer version 21 is available in GNAT Tracker in the documentation section of the website. A focus of the CodePeer team has been to identify many of the different use cases for CodePeer in a typical software development lifecycle so that we can tailor solutions to fit the needs of our customers. We have identified that CodePeer is used at many stages of the software development workflow with various setups and settings which best suit the user's requirements. For example, a user can utilize Level 0 or the Infer checkers from CodePeer at their desk to check for any glaring logic or runtime issues prior to a code check-in. Developers can also benefit from the results of GNATcheck to ensure that their source code does not violate the coding standards set by the project. CodePeer has been designated as a CWE-compatible tool by the MITRE Corporation, which means that CodePeer can map relevant findings to the Common Weakness Enumeration Security Standard. For more information on CWEs and CodePeer's mapping capabilities, visit www.adacore.com/CodePeer. CodePeer ships with a Jenkins plugin that IT teams and DevOps engineers can use to integrate CodePeer into a Jenkins build environment. CodePeer, GNATcheck, and GNATmetric also can display results in continuous monitoring dashboards, such as SonarQube, to enable the visualization of a program's metrics, such as technical debt. For current subscribers of CodePeer, you can access version 21 of the software by logging into GNAT Tracker. For users who are looking to add advanced static analysis to their Ada software development environments, you can contact us for more information and pricing at sales@adacore.com or fill out the contact form at www.adacore.com/pricing. Please visit us at www.adacore.com to find out more about all of our software development products and reach out to us with any questions. Thanks for watching.